Hi everybody, welcome to one more of Mrs. John's lesson. This is the second lesson for year 12 on static electricity, and in this lesson I'm going to be talking about two things. One is electric potential energy and the other one is about having a stationary charge between two oppositely charged plates. How can you hold a charge stationary? Has to do with Millikan's oil drop experiment. Okay, so the first thing, just going on to electric field strength, and electric potential energy. So if you have two oppositely charged plates where you have one of the plates is positive, the other one is negative, so you've got a potential difference between them and you have a uniform electric field between the plates. Okay, now if you could have a positive or a negative charge. Let's say you have, doesn't matter, let's say you have a negative charge here. So what happens if you have a negative charge is that the negative charge is going to feel a force and get attracted to the positive plate. So if it was free to move, it will move in the direction of the electric field, or it will move towards where it likes to go. So when it does that, it's going to accelerate and it's going to gain kinetic energy. And what is it losing? It's going to lose electric potential energy. Now, in order for this negative charge to gain electric potential energy, you've got to force it to do something it doesn't really like to do. It's the same analogy with gravitational potential energy. If you have something and you let it go, what would happen? It will drop and fall down because of the force of gravity pulling it down. So it's going towards the direction of the gravitational field, and when it accelerates down, it's gaining kinetic energy, but what is it losing? It's losing gravitational potential energy. In order for something to gain gravitational potential energy, you've got to lift it up, or you're doing work against gravity. Same thing with electrical potential energy. In order for a charge to gain electric potential energy, you've got to force it, okay, and hold it against the field, so that this is something, in order to keep it there, you've got to hold it down, you've got to force it to be there. So it gains electric potential energy when it moves against the field. So how do you know how much electric potential energy has been gained? So whenever energy is changed from one form to the other, work is done. Okay? So that's the work done in holding a charge there. And work is equal to force times distance. Now, what sort of a force is this? This is an electric force. And we learned in the last lesson that electric field strength is F over Q. And if you rearrange this, you get F is equal to EQ, where E is the electric field strength. So this electric potential energy can also be rewritten as, in place of F, we can write this as EQD. So this is one way of calculating the electric potential energy that a charge could gain. If you let it go, this electric potential energy will be changed to kinetic energy as it accelerates towards the plate with the opposite charge. So you can also find out the speed with which a charge will hit the other plate. If you convert this electric potential energy gained is equal to the electric potential energy lost is equal to the kinetic energy gained, and that's half mv squared. So you equate the half mv squared equals EQD. You can get that. How do you find E? The way to calculate E is equal to V over D. Okay, voltage across the plates divided by the distance between the plates. So that's what you do. So you can actually equate all this and you can get electric potential energy in another form. In place of E, you can have V over D. And you got the Q and D. So that cancels out. So you can also have electric potential energy is V times Q, which is actually the definition of voltage. Voltage is the amount of energy carried by charge. Okay, so that's the definition for voltage, how much electric potential energy is carried by charge. So there are many ways of finding out the amount of electric potential energy. So that's one part. The next part is about holding a charge stationary in an electric field. And why am I saying this? That's because there was a person called Millikan who actually found out the size of the charge on an electron. And he did this experiment by holding two plates with opposite charges, and he had an atomizer which was charged, and he was having these droplets fall between the plates, and he was changing the voltage of the plates till this charge was stationary. So just looking at this, it could be positive, negative, doesn't really matter. If you have a charge that's held stationary between the plates, the moment you see the word stationary, what you need to be thinking of is balanced forces. So what are the forces that are balanced? There's two forces acting. So one would be the force of gravity, and the other one would be your electric force. So when your gravity force is equal to the electric force, then it's balanced. Your gravity force is m times g, and your electric force from here, F is equal to E times Q. So it's electric field strength times Q. And so how do you find the value of Q? It is mg over E. Okay, now, and your E, we know, is V over D. So in place of E, if you go mg divided by V over D, you get Q, or your Q, just rearranging it all, is mgd over V, voltage. So that's how you find the size of the charge. Sorry, that's just hidden now. So here we go. Okay, so I hope that helped. Bye for now.